Welcome everyone. Today, we're diving into the wonderful world of physics and exploring Sir Isaac Newton's second law of motion. This law explains how forces, mass, and acceleration are all interconnected. By the end of this presentation, you'll have a clear understanding of these factors and how they affect each other. So buckle up and get ready for a thrilling ride through the world of motion. So what is force? Force is any push or pull that can cause an object to change its state of motion. Force is measured in newtons. Force has both magnitude, strength, and direction. Imagine you're trying to push a stalled car. The push you exert is a force. Force can be a push, a pull, a twist, or even a friction between surfaces. It's anything that can make an object start moving, stop moving, or change its direction. The strength of the force is its magnitude, measured in newtons. Just like a strong wind has a higher magnitude than a gentle breeze, a harder push on the car exerts a greater force. Additionally, forces have a direction. The push you give to the car has a forward direction, while gravity pulling it down has a downward direction. So now, we will demonstrate force. Gentle kick a ball on the ground. Observe the slow roll. Kick the same ball with more force. Observe the faster roll. Let's see force in action. In this experiment, we have a ball resting on the ground. Give the ball a gentle kick. The ball rolls slowly because the force applied is weak. Now, give the ball a strong kick. Notice how the ball rolls much faster. This is because the force exerted by your kick has a higher magnitude compared to the gentle kick. This demonstrates how the strength of a force affects the motion of an object.
What is mass? Mass is the amount of matter an object contains. Mass is measured in kilograms. Mass is a property of the object itself, independent of gravity. Mass is often confused with weight, but they are not the same. Mass refers to the amount of matter an object has regardless of its location. Think of it as the stuff the object is made of. We measured mass in kilogram. A bowling ball has more mass than a tennis ball because it contains more matter. Here's the key difference. Weight is the force exerted by gravity on an object, which depends on its mass and the gravitational pull of the environment. So, an object might have the same mass on Earth and the Moon, but its weight will be less on the Moon due to weaker gravity. Demonstrating mass and its effect. Place a stone and a coconut shell of different masses at the top of a ramp. Release them simultaneously.
What is acceleration? Acceleration is the rate of change of velocity, speed, and direction. Acceleration is measured in meters per second squared. Positive acceleration means speeding up. Negative acceleration means slowing down. Acceleration is all about how quickly an object speed or direction.
Newton's second law. Newton's second law of motion says that the amount of force applied to an object affects its speed. For example, when Tony's car breaks down, he'll need to push it. The more force he applies, the faster the car will move. But this law has a second part too. The speed or acceleration of an object also depends on its mass, whether it's lightweight or heavier. If Tony pushes his bicycle with the same force he used to push the car, the bike moves faster because it has a lighter mass. There are three elements at play here: force, acceleration, and mass. Mass is the amount of material an object is made of. The weight of an object depends on its mass. In Tony's case, his car has more steel, glass, and aluminum, so it's heavier and more difficult to move than something lightweight, like his bike. Let's take another example: shopping carts. Whatever the cart is made out of, metal or plastic, makes up its mass. When you apply force to an empty cart, it accelerates rather quickly. That's because the mass of an empty cart is lower than a full one. It's easy to push at first, but as you add your favorite foods, the cart slowly becomes heavier. You'll need to apply more force in order to keep it moving forward, since the total mass of the cart grows with each item added. Just remember, the amount of force needed depends on how fast you want an object to move, as well as its mass. Feel free to check out our video about the third and final law of motion.
GCF Global, creating opportunities for a better life.
Mass is a measure of an object's ability to resist being accelerated by a force. That means the more massive an object is, the harder it is to make it move if it's at rest, or to stop it if it's moving. The nifty thing about mass is that it doesn't necessarily have to do with size. Think of a big pile of rocks and a big pile of feathers. Both piles are the same size, or volume, but it would take a lot more effort, or force, to move the pile of rocks than it would to move the pile of feathers. The reason? Rocks have more mass than feathers because they're more dense. To show how it's harder to accelerate something with more mass, picture a student and a teacher each sitting at rest in a rolling chair, facing each other. Let's also say the teacher is more massive than the student. When they both push off each other, they go rolling backwards. Notice how the student goes back much farther and faster than the teacher. The teacher accelerates less, since she is the more massive of the two objects, and it takes more force to accelerate her than it does the student. All this has to do with Newton's second law of motion, F equals ma. It says for a set acceleration, an object with more mass requires more force to get it moving at that set acceleration. As mass increases, the force required to accelerate or decelerate that mass increases as well. Now, don't you feel massively smarter?